So a little bit about myself. My name is Mark Shields. I work for QC. Obviously, I'm based in Charlotte, North Carolina. I started my career at QC in December of 2014, so I will hit my 9-year anniversary this December. And it's been really cool. It's been an awesome experience. Working with various DOTs across the US, I've learned a lot about their likes and dislikes, the challenges that they face, everything from the counters that they prefer through how they like their data delivered. Every program's a little bit different, a little bit customized, so it's been a really interesting experience working with so many folks across the US. So I do have experience managing a lot of data collection projects. I started in operations back in 2014, managing really like small impact studies or traffic impact studies all the way through managing statewide count programs for North and South Carolina. And I am sort of our resident aerial data collection expert. We do a lot of drone data collection, a lot of fixed wing aircraft data collection for things like parking studies or interchange OD. A lot of those projects that we've completed using aerial photography or videography, I've managed myself, so I probably had some hands in making that stuff happen. So moving on, who QC is. So we are a nationwide data collection firm, if you're not familiar with us. We are employee owned. We've done work for close to 5,000 different engineers across the US, having completed about 25,000 projects, and we've performed well over 250,000 counts in our 20-year history. So just a plethora of experience collecting a variety of different data for a variety of different DOTs with their own unique requirements. Some of those DOTs are listed here, where we've performed, coverage count programs, just routine TMCs, tube counts, OD. We've also done quite a few statewide horizontal curve assessment programs, in particular for KYTC, New York State, South Carolina, and Ohio. So we surveyed all of their roadway network, capturing ball bank data, horizontal curve data, which I'll get into in a little bit further in the slide deck. So before I dive into what we do and how we do it, I did want to talk a little bit about project management. If you're not familiar, QC has an online platform called MyQC. It's built into our website. So if you go to qualitycounts.net, on the top, there's a little login button. You can create an account, or if you've placed an order with us before, you actually have an account already. You may not know this, but if you run a password reset, you should be able to get access. MyQC is a really cool system. This is a screenshot from the application. We use this program to manage all of the project work that we do for clients across the US. So whenever you're requesting counts, you can go through this, or you can just email us whatever the requirements are for your project. We input it into the system, and this system is sort of like our one-stop shop for everything related to your project. So estimates, invoices are all there under documents widget. You click a documents button and all your stuff is basically just right in front of you. At the click of a button, you can get all of your TMC or tube count data downloaded from our database. No matter how large the project is, it's likely that data is stored here. And we can also, or we do also store our video in this system as well. So if you've requested turning movement counts from us in the past, you can actually log into the website, see the projects you've ordered, and download the video footage that's associated with those data collection projects. So if you want a little bit more insight into field conditions and what's happening in the survey area as we're out there doing project work, MyQC is a really great resource to check those things out. Just another screenshot from the application. As you can see, this project was for NCDOT. We have all the locations mapped here, all the time periods that we collected. And then once the project's complete, the PDF reports and CSV reports get hosted on here, as well as video links to the accompanying footage for those locations. So again, if you haven't logged into MyQC before, I highly recommend it. It's a great application for managing all your data collection needs. So talking about project lifecycle, there's really a variety of types of data that we collect, also a variety of technologies that we use, but they generally follow a very similar process. We set up everything in the field, we verify field conditions, ensuring that we're collecting when roadways are following a functional norm. After that video or that data, if it's from a traffic counter or from a camera, it comes back to the office. We do a pre-check. It's really just like at-a-glance quality control. We're looking for things like traffic incidents, the signal going out, anything, significant queuing that could potentially impact the data or impact vehicle flow from intersection to intersection. All those things are things we look for as we're doing that pre-check. When it comes to tube counts, it's just an at-a-glance view of the data just to see that all the tubes were taking hits throughout the count period. And then also looking at the actual hit pulses themselves to ensure that there's no double counting or anything like that occurring, which again, I'll get to a little bit more in a minute. We run all of our data through a QC automation tool called MERLIN. MERLIN is an application we designed specifically to manage turning movement count and TMC data. I'm sorry, tube data. And you can input that data into MERLIN to quality control it. And it'll spit out a report of any flags, any inconsistencies in the data that we can then investigate further and verify before we send that data off to our clients. And then when it comes to delivery, I think the vast majority of the clients that we do work for require custom reports. We do have standard web reports that, again, you can download off of MyQC, but we do a lot of custom reporting as well. So if you are using a GIS application, if you're using MS2, if you're using Drakewell, what's the other one? GeoCounts, any count management system really that you're using, or our own count management system, DataPoint, we can create deliverables that meet those requirements. You can directly import into those systems just for ease of use to take a lot of the work off your plate. So again, everything kind of follows a similar project life cycle from start to finish. When it comes to camera counts, we use a variety of technologies for these. So MyVision Scout units, we have a couple of those that we use in some of our offices. We have about 1,000 proprietary camera systems that we use to record up to 3 days. More recently, though, we've been heavily invested in SPAC solutions. Their CC3 Plus units are really great. Highly recommend them if you're looking at an alternative to MyVision or any other kind of camera system you're currently using. They're definitely worth checking out. But no matter what, that technology is generally set up in the same way. We set up in the corner of an intersection, or we set up in opposing corners of an intersection. If it's over, about 150 to 200 feet from quadrant to quadrant, we'll set up in opposing corners to film an unobstructed view of all traffic at that location. So we're looking for, all the vehicle movements, obviously, at those locations. We're looking for bikes and we're looking for pedestrians. If you weren't aware, we don't charge extra for bikes and peds. They come, as a default in our deliverables. We always count them. Bikes are generally treated kind of like vehicles, left through right turn movement per approach. And then pedestrians, we count per approach as they cross each crosswalk. When we're on site, we're filling out field paperwork to give as much detail to the data processing team as we possibly can. So that's what is shown on the left here. Those are one of our TMC checklists. So we draw the lane diagrams, we specify camera placement, we specify what the businesses or residences are in each corner to verify that we're in the correct location. And then any special notes that we need to add, we'll throw in there at the bottom. So on this particular project, this is actually one that I set up a couple of years ago. So that's my terrible handwriting on the screen. There was construction on College Street opposite the interstate from where I was setting up, and the queue was backing up onto the roadway that we were on. So anything deemed relevant to data analysis, to data interpretation is added to these checklists to make sure that that information is then pushed over to you, so you have that info as you're assessing how to redesign an area, how to retime signals, or whatever the end use application is of the data that we're providing. There's also a setup checklist on here that's really just for internal use. So we will go through that checklist and make sure that, the camera is synced, that the memory is formatted, that we have enough memory to record the location, that we're at the proper height, that we marked all of the things on the checklist that need to be marked up, like the camera numbers, the SD card numbers, landmarks, anything that we deem useful to data interpretation is going to be on these checklists. And it helps our processing team know how to process the data and how to format everything correctly for the end user, which is you guys. When we get to the pre-check process with the TMC, we're looking for a lot of different things. So all that video is reviewed manually before we send it to actually process and tabulate the count data. So we're looking at things like the viewing angles. Is the viewing angle appropriate? Like, can we see all the movements clearly? Can we see all the intersection approaches clearly? Can we see crosswalks and PEDs actually using those crosswalks? We want to make sure that the intersection is fully countable before we send it off. Otherwise, it might be a situation where we need to go back in the field and refilm that location for an additional survey period. Any incidents or disruptions are always reported, so those are things we're frequently looking out for. Anything odd that, again, could impact traffic flow, could impact data interpretation is going to be noted and sent to you alongside the data. We're also looking at queue and delay. So as you can see, this is, again, from that project that I did a couple of years back, where the queuing backed up to the intersection and these vehicles making westbound rights started to stack a little bit. Again, any relevant information like that is stuff we like to pass on to ensure that you're fully aware of what field conditions are like without having to go into the field yourself. The data itself, though, we count manually or through an application called DATALENS. So DATALENS is our more recent kind of foray into AI. We are using a machine learning algorithm to detect vehicles, classify them, timestamp them, and bin them properly into 5, 10, 15-minute intervals, whatever your desired interval length is. At the moment, we can do up to 4 class bins. We're refining the detection model on an ongoing basis. It's always going to be something that we're going to be working on to continuously improve what detection looks like and making sure that the AI produced counts are as close to ground truth as possible. So every single time we're doing an AI count, we're also validating that information with a manual count to ensure that the data is actually correct. It does result in faster turnaround. A lot of the videos that we process, as soon as we upload, they automatically get counted. So it's really, really quick. And then we just have to go in, add the gates on top of the trajectories, and then we can get the little, kind of it's like a micro OD study almost. They went from the northbound gate to the eastbound gate, or the westbound gate to the northbound gate. We can determine the turning movements based on the trajectories from each gate to another gate that we create on screen. So that process doesn't take a very long time. And then we QA the data. So right now we're working on building QA automation tools into DATALENS. We'll likely show this off in a future innovation webinar to showcase the program in more depth. But at the moment, working on the QA/QC component of the application. Right now, we take all the deliverables out of the system and run them through MERLIN, which I'll talk more about in a minute. But that QA will soon be built into the application. And we are, well, I tell my CEO I'm telling you all this, but we are actually planning on releasing DATALENS to the public down the road. So it will be something that you're going to be able to process your video through on your own, should you desire to do that on your own. If you prefer to have us do it, that's something we can obviously take care of for you as well. So these are some screenshots from MERLIN. MERLIN has an interface that allows you to place intersections alongside one another to check the flow among those intersections during the count period. And it will do that on every 5 or 15-minute interval. We can also set custom thresholds for flags. So say, for instance, like we set a threshold for if 0.5% of overall volume disappears between these locations, it's going to set off a flag. That's an example of just one customizable flag that we can do. There's also illegal movement flags. There's flags on 0 intervals. There's flags on sudden dips or spikes in traffic. We also flag unusual class distributions. So say, for instance, you suddenly get just a wave of trucks coming through. The system will actually identify those instances and flag them for further review. Every single TMC that we do is run through the system. Every one of them produces a flag report, and we investigate those flags before we send the data off to our clients. And by having a graphic interface like this, where we can set these intersections alongside one another, it really gives us an opportunity to ensure that the intersection orientation is correct as well. I mean, as you may know, when you're setting up hundreds of cameras a week and filling out all these field checklists, it's kind of an arduous process to go through all that footage and make sure that it's all oriented properly. So this program facilitates making sure that those intersections are correctly oriented, that your northbound is actually your northbound, east, west, southbound are all correct. And then we check for, again, those kind of minor errors that may come up during the count duration. As a result, you end up with a flag report. So this is a flag report from a project we did up in Ashburn, VA, where our quality control specialist, Alex, went through and looked at each of those flags and put in some notes to explain what was going on. So for example, this particular location had a balancing issue. northbound and southbound imbalance caused by westbound right and southbound right movements not counted at an adjacent intersection. So that explained what was going on between these movements to ensure the client was aware that, that yes, there's an imbalance issue between these two locations. No vehicle warning. There were no vehicles during an interval. So that was confirmed. There's also impossible movements again. So there was a flag for that, a westbound right occurring where a westbound right shouldn't have occurred. So we go back, we review the video, we confirm that those things are indeed happening. We put all of that in a report, and that report gets delivered alongside the data when your project is finalized. And when it comes to segment counts, really, tube counts are still kind of the tried and true method of doing this. Where speeds or volumes are too excessive, or where maybe we're too close to an intersection, you're going to get some queuing over those tubes. It's going to impact the data. It's going to impact even just basic volume data. It's definitely going to impact classifications. We use cameras or side fire radars to collect that information. So Wavetronics and Houston radar have been our go-to over the years. Wavetronics Smart Sensor HDs in particular, we have about a dozen of them, and about 10 to 15 Houston radar speed lane units that we use. They're both side fire, so you just set it up perpendicular to traffic flow. There's an entire process for setting those up where you QA the data on site. So you're actually looking at the data, the vehicles appearing on screen on a tablet, and verifying that the information that's appearing on the tablet is indeed what's actually happening in the field. So we'll do a test count on site to verify the validity of the data that's appearing on whatever tablet or laptop we're using to set up those radars. But again, a lot of our stuff is still collected with tubes. It really is kind of the tried and true method of collecting segment data. We do have field checklists that we go through for this process as well. I don't have one of those on screen, but it looks like, the tube counter placement, where adjacent or where roadways are by that setup location. So, X roadway is however many feet downstream, Y roadway is however many feet upstream, just so we can verify the exact placement of the location that we're setting up. And then we draw the lane diagrams, we draw the tube count or tubes going across the road, label them all. All that information is there just to make sure that it aligns with how we program the counter, which also should align with the resulting data as it's viewed and then as it's put through MERLIN. So all of these things have to kind of be in check. It's really a multi-tiered, multi-layered QA process to ensure that the data is valid, that the data is correct, that the directions are correct, and that you're getting good information. So we do data pre-check with segment counts. That's really just checking for obvious errors. Do we have tube counts or tubes that went dead during the count? Maybe they were dislodged, maybe they have a hole in them, maybe they're waterlogged, whatever the case may be. We do check for those sort of inconsistencies in the data before we start processing and producing deliverables. And then processing and deliverable creation happens in a variety of ways. That could happen through using Trax Pro, which is a JMAR product, Vias, which I think is a time mark product, Centurion, which is a Diamond traffic product, and then Data Express is Wavetronics, and Stats Analyzer is Houston Radar's application. So we have a ton of experience using these various applications to look at the data, QA it, process the counts, and send that stuff off to you. And everybody has kind of their own preferences when it comes to the QA percentages and the thresholds that we set for certain errors. A lot of DOTs have preferences on what type of counters we use. So we try to have really a broad assortment of tools to make sure that we're using what you want us to use and what you have faith in as we're out there collecting data. We don't want to use anything that you're not fully confident in its ability to collect data on your roadways. When it comes to actually processing segment counts, so we look at the sensors. This image on the top left is from Trax Pro. You can see time-stamped hits or time-stamped air pulses on each of the tubes as those axles cross. So this was just a two-axle vehicle driving across. You could see it hit the A tube, B tube, C tube, then D tube, and that's time-stamped down to 1/10,000th of a second. Field setup verification. So again, we check that information against the field checklist that we fill out when we're in the field. And then within the applications, we'll make any adjustments to tube spacing or dead time that we need to make to ensure that the data is as accurate as we can possibly get it. Spacing, we can adjust up and down, like basically by the inch, depending on, maybe it's a high-speed facility and tubes moved a little bit. Maybe they bowed out a little bit during the survey period. We can make slight adjustments as we're processing that data to ensure that you're getting a product that is accurate, that it matches the TMC volumes nearby, and that it also is within a reasonable threshold of any previous counts that you've collected at that site. So as part of our data quality review, a lot of times DOTs will have us upload that data to MS2, for example, and actually QA the data by looking at our data against historical. And if it's outside of a particular threshold, we'll generally go back and collect that data. If the first set of data is confirmed, we'll roll with that. If it turns out that the data is completely different, we can go with whichever one looks better, or we can go out there a third time and recollect again just to make sure that we have consistent results more than one time, so that you're getting, again, data that's completely valid and proven. We want you to get ground truth. We also review our unclassed percentage as part of that process. So JMAR counters in particular are pretty good about this. They will report an unclassed percentage of vehicles that it can't really determine what they are. And with that unclassed percentage, we can do a lot with it. We can leave it as is, so that you can actually see, okay, this count is, say 95% accurate with a 5% unclassed rate. Usually about like between 5 and 10% is typically our limit. Usually that's specified by the DOT we're doing work for, by the client we're doing work for. That'll determine whether we need to go back out there and recollect a second time to verify the data, or if we're okay just submitting the data as is. Unclassified data can also be reallocated. So we have some clients that prefer that data be rebinned as PVs. We have some clients that prefer that the data be distributed proportionally across all classes. All of that stuff is possible. Really just depends on what your preferences are. So we have a similar application of MERLIN, but it's called tube flags. This report is run against the tube data that we have uploaded to our traffic count database in MyQC, and it's going to look for a variety of errors. It's going to look for some general errors like, did you collect on the correct day of the week? Is the duration, does that actually meet the full duration of the survey period? So if you asked for 24 hours, did it capture 24 hours? Is the duration atypical? Is it short an hour? Are there volume errors like zero volume gaps or peaks or abrupt changes in volume or uneven volumes, intervals that spike, atypical peak hours, and then class and speed errors like high unclassed, weird shifts in class distributions, excessively high speeds or excessively high truck percentages. Those are all things we generally investigate further just to make sure that the data is actually valid, that we're sending you something that is indeed correct. Parking studies are another service that we offer. So there's a variety of ways to do these. I'm going to actually do another webinar in the coming months to cover parking studies in greater depth, but I did just want to show a little bit about what we do. There are 3 approaches that we generally take for these, really 4 approaches. The first one, don't have it listed on here, but it's kind of the tried and true method of just going on site and counting vehicles. We do that routinely, especially for small parking lots where we have a very long collection window. So if it's hourly intervals, we'll generally go on site and just, with a clicker, count how many cars are parked or how many unoccupied spaces there are to assess what parking occupancy looks like. We also do turnover studies. So with turnover, we have a tablet system where we can enter license plates in from interval to interval, compare those plates and tell us what vehicles are new, which ones are still there from the previous interval, or if it's an empty space, obviously there's no vehicle there. We have that change of occupancy recorded as well. We do have semi-automated approaches for data collection as well. So by semi-automated, I mean that we have cameras that we set up on a vehicle, we'll drive around, and then we have software that will identify the plates, and we basically go through each plate image and verify the plate was detected correctly. So that's looking at, however many, the first several digits of the plate at least, verifying that those are indeed correct. And then we can resurvey that area however many times need to be resurveyed, and then compare the plates from interval to interval to get your turnover rate. Drones and fixed wing are a little bit newer. Drones, we've been doing drone projects since 2016. We have a variety of partners in this area. So we have nationwide coverage with drones. Usually drones are best for small study areas. So when we get a request for an aerial survey, I'll use an application called AirMap and just look at the airspace, see where there may be issues with the classification of that airspace. So say we're near an airport, that's going to require approval from FAA. That's something we can submit on site. You generally get approved and we can go ahead and continue with the study. We're looking at any sort of obstructions in the area, things that we need to look out for, tall buildings, what have you. Anything that could impact or create interference between us and the drone and impact the study. Those are things we're kind of looking out for as we're scoping these things out. For larger study areas, or for example, like an area that, maybe you have to fly outside or beyond visual line of sight. Maybe the survey area just covers it's just huge. It could be an entire city. We generally use fixed wing aircraft for that. We will fly a Cessna 172 overhead in just kind of this back and forth pattern along a grid, and take an image with a really heavy duty Nikon camera about every 2 seconds. That route that we fly is planned in an application called Drone Deploy. So Drone Deploy, obviously, as the name implies, it's used for drones, but you can still use it for fixed wing data collection. We will take all the images and upload them to Drone Deploy to stitch together into individual orthomosaics that we then use for data processing. And this is what the end result looks like. So this map is from a project we did for Belle Isle up in Detroit just last year. We flew a Cessna 172 overhead 38 times, I think was the number. So about 38 intervals of data, 38 hours flying overhead, back and forth in that grid pattern, taking images every 2 seconds. The end result is that we had like somewhere from 9,000 to 10,000 images that we had to process and stitch together. But it creates a really cool map. If you're looking at site conditions like parking, or you want to see maybe what queuing looks like over the survey area during several intervals, this is a really great approach to do that. We've done several interstate studies using the same approach, where we take images as we're flying up and down an interstate to look at queuing and look at bottlenecks. We actually did the same here because we were looking at queuing over the bridge to see how bad that got as it hit the mainland. We've also done some more unique studies. So out of these images that we captured, we were actually able to see individual temporary shelters that people set up. We had to do shelter counts as well. So we were doing a lot of ground level data collection alongside this. But these images, really anything you can see, you can turn into a data set. So we actually went through and counted all of the temporary structures so that the agency could see, okay, this is what demand for like park pavilions or park like picnic spaces actually looks like. People were setting up their own spaces, but if they were to provide more, they'd likely be utilized, because we were seeing like dozens, if not hundreds, of temporary shelters set up across the island during peak periods. Now, when you zoom into this, this is what it looks like. So this is actually an overhead view of the entire island, but in the image is just absolutely massive. But you can zoom into about this close, like you could on a normal like Google Map aerial, and count individual vehicles. And there's enough quality here that if you wanted to count like per spot, if you are looking at turnover, if you want to know, ADA, if you want any sort of like special permits separated out or areas separated out or delineated in any other way, it's possible to do with this approach, because you have such excellent clarity and such a great vantage point when you're collecting aerial imagery. This is also a really powerful tool in public meetings. I've done a few dozen parking studies like this, either with drones or fixed wing aircraft. And we provided those images to our client, and they went into a public meeting and said, you don't have a parking problem. You have, or not, it's not a problem of parking availability, at least. There are spaces all over the place. They're just not in the core area of activity where people would like to park close to where the action is happening, whether that's like a downtown area or some sort of special event area or what have you. So it's a very powerful tool for public meetings to really showcase, like, this is what conditions look like, and then figuring out ways to improve those conditions through the engineering and planning work that you all do. I'll touch on Riker products. So we do horizontal curve assessments mainly for state DOTs, regional DOTs, and municipalities or counties. The reason we do this is because accidents are very prevalent in curves. I think it's something like a quarter of all roadway departures happen in curves, I believe is the percentage. I might be misquoting that, but in order to prevent those, we do want to look at the signs that are present going into those curves, the advisory speed, the chevrons. We want to look at the curve geometry itself, and all of that is recorded using Riker CARS system. CARS stands for the Curve Advisory Reporting Service. What it is basically a modern day ball bank indicator. So it is a digital inclinometer that you set on the dashboard of your vehicle, and as you're driving around, it's connected to a tablet and a GPS Trimble unit mounted at the top of the vehicle. And as you're driving, it will record the curvature of the roadway and the incline that you're experiencing as you're going into the curve and coming back out of it. So rather than having to manually ball bank and go back and forth and read a little device in your dashboard and take notes as you're driving, which is super dangerous, this is a very passive approach to collecting curve data. Usually when we're doing these projects at the same time, we're collecting sign inventory information. So we are using an application called SignProx to review the video and then annotate and geocode the signs that are present around those curves. As a result of all this work, you end up with sign recommendation reports. The system will tell you or make recommendations as to how many chevrons you need, what the chevron spacing should look like, what your curve advisory speed should be. And that way, if you have all that information, you have the SignProx database, you can actually see from the 10,000 foot level view where your signs are non-compliant, where you need new signs, where you have incorrect signs. All that is possible by using this kind of passive data collection system. All you have to do is just drive around. You drive each direction of each road twice, and that'll produce all these reports for you. But yeah, we've done statewide programs, like I said earlier, for New York, Kentucky, Ohio, South Carolina, and everybody we've done this for has been really pleased, and we've managed to survey their entire roadway network in just a few months' time. Last thing I'll touch on is DATAPOINT. So DATAPOINT is our project, is our data management system for TMCs and segment counts. So what it is it's essentially an online application where you can store all this data. The data deliverables that we produce out of MyQC do port over directly into DATAPOINT. And we've seen really a variety of use cases for DATAPOINT. It's been pretty cool since we developed this. Some DOTs use it to manage all of their data, as you would expect. There are other clients that we have on the private side that have been using this as a project delivery mechanism. So they input all the data that we've collected into an instance, into their very own unique instance of DATAPOINT. We add GIS layers on top of that. So you can actually click and activate certain layers. You can view, say, your roadway network where you have greenways. You can look at crash data. You can look at just a variety of different types of data. And have those stack as layers on top of your count data. And then this can get delivered to your client as sort of a, just a really cool value add where they can look at, volume to capacity ratios and intersections. They can perform citywide analysis on their speed data to see where there are speeding issues. And then you can also do scenario analysis. So with the scenario analysis, you can make modifications to the lane geometries at intersections or make modifications to the traffic flow at intersections and see how that impacts the resulting VC ratio. This is all based on the HCM planning methodology. We're not quite at a point where we go into like level of service and that kind of thing, but it is a neat tool to have. Again, just to get like a 10,000 level foot view of like what your roadway network looks like during the AM, midday, or PM peak periods. So this is what the scenario generation tool looks like, or at least parts of it. This particular count was from 2022. You can sort down to the exact time period that you want, whether that's AM, mid, or PM. It's going to show you what the volumes look like, pedestrian volumes, percent of heavy vehicles, and then you have to input other information, whether there's parking, left, and then you enter in your left and right turn signal phasing, and it'll spit out what the VC ratio is of that location. So in this case, it says this one's near capacity. But if we make modifications to these numbers, if we add lanes, or change different variables within this scenario generator, it'll adjust the VC ratio, and you can actually save that and export it into a nice little PDF report to show you exactly like what the roadway would look like and what the VC ratio would look like by making modifications to the infrastructure or to the count. So if you expect that an area is going to grow, say we want to add 1,000 additional northbound throughs to this, you can do that and it'll automatically update that VC ratio to give you a better sense of what future conditions may look like. The last thing I'll touch on is safety, since we're kind of coming up on time. Safety is really critical for us. I do want to touch on it at least just for a moment. In our 20 years, I can't think of a single safety incident of significance that's been reported. One of the cool, more recent developments that we've had, though, is with Samsara fleet tracking systems. So for those of you that don't know what Samsara is or really don't have a lot of familiarity with fleet tracking, we have GPS-enabled dash cameras in all of our vehicles. And the cool thing about that is we can use that to audit our field setups. We can audit where we set up as well. So we can use that to verify that we were in the right place at the right time, that we collected the data at the right time. All that information is really at our fingertips, so it's available to you in the event that you want anything to verify the validity of what we're doing. We also have, various like cell phone applications that take images, but also not just images, but they burn in the GPS coordinates and the direction that we're facing and the time and date into those images, so we can use that for field verification as well. So really, we do this for employee safety and safety of the public, but it is a cool additional resource available to you all in the event that you want to go through and, basically just audit the work we're doing. All this stuff is openly available in the event that you want access to it. And that is all I have for this session. And then I'll take a look at the chat, see what questions we have. If you do have any questions, go ahead and feel free to answer them. I'll just answer them in the order that they were added. For turning movement counts, can QC provide RTOR volumes at signalized intersections? The answer is yes, as can DATALENS. So the iteration of DATALENS that we're about to release this Friday, actually, so tomorrow, does RTOR. And that will show up in the reports that are hosted on our website as well. So if you have a project that you've done for us, you go online, download the reports. Assuming you've requested RTOR as part of that project, it is something we'll add to the count, and that data will be uploaded to MyQC, so you can download those reports and see your RTOR data. Can QC count school bus loops and parent pickup drop-off areas, looking at volumes, queuing, carpool data, et cetera? Any experience or comments on this type of collection? That is a very good question. North Carolina is a very interesting state in that they have a fairly robust school studies data element to their data collection on-call RFP. So we are asked to generally cover an entire campus rather than just specific intersections. And that is what we're looking for. They actually request that we look for vehicles that are dropping off their kids on the main roadway, not actually at the school itself. We're looking at circulation into the school, out of the school. We're looking at queuing and just general traffic backup on the main roadway. All that information is available when we do that work for NCDOT. Obviously, we can apply that to any DOT that has that sort of request or any client that has that sort of request. A lot of that data we'll collect with drones, just because having that aerial perspective gives you a much better sense of everything that's happening in the field. It gives you a perfect aerial perspective of the entire queue as vehicles arrive, as they go through the school circulation, and as they exit. So you get really just the ideal view of everything that is happening on that school campus. So yes, that is definitely something that we do. Can we send QC traffic count videos that we've taken for them to process the count data? Yes. We do provide count support services. That is something that we offer. Right now, we do have several clients, cities that have switched from MyoVision over to using us because we have a little bit more customization that we can do in our reports. Turnaround is usually really fast. So that is something that we do offer. As DATALENS is developed further, it's going to be something that we open up to other users, outside users, peer data collection firms, engineering firms, DOTs. It'll be something that you're going to have access to be able to process your footage yourself. But if you prefer a hands-off approach and would rather just send us a batch of files through Dropbox with some setup checklists to tell us where, what approaches we're looking at and what location we're looking at, that's another way we can do that as well. And we do routinely provide that service to DOTs. Would you be able to provide a copy of the in-field checklist you mentioned? I know you rattled off some of the items that are checked off during setup, but I'd like to have a look at it. Absolutely. When we follow up with the link to the webinar recording, I'll include a copy of the counter checklist in that for each tube count and a TMC report. How you collect, detect cues, and how you account for variations from cycle to cycle in signalize or at stop control approaches. Great question. So that's fully customizable. Like anything we do, everything is highly customizable. So usually when we do queue studies, we're looking at every cycle of a signal to see how far back the queue extends, and we report that in number of vehicles, and we can classify those as well if need be. We do that per lane or per approach. We can also, we report it in number of feet. We can map that stuff out. So you can get like an aerial view of how far back the queue extends from intersection to intersection. Usually by setting up cameras facing the approaches is how we capture that information. The only thing that we ask if we're doing a queue study for you is that you try to give us a sense of about how far back those queues extend without really knowing what field conditions are like. It's hard to assess like how many cameras we need along an approach to fully capture that queue. But usually we can like use Google Map traffic, historical view to kind of guess where the queues extend, and then we'll set up cameras covering that area, usually more than we need, to make sure we get all the way to the back of it. And again, that data can be delivered per signal cycle. We can do it in a certain interval. We can deliver it as feet. From the stop bar, we can deliver it as number of vehicles. We can do that per lane. We can classify the cars, like whatever you need. If we can see it, we can turn it into a data set. I missed the first 25 minutes of the presentation. Oh no. Are you doing OD data collection? Yes, we do OD. We recently discontinued Bluetooth OD, mainly because the units we were using were giving us some trouble and it wasn't a very high demand service. But we do still do origin destination studies, either from the air, using like a tether drone or even fixed wing if need be. We also use high definition cameras set up at ground level to capture license plate data. And that stuff, we can run through that same program we use for parking studies to detect the plates, give us some number of digits on the plates, and then, or characters on the plates. And then we can, run or do our math in Excel to search for matches from point to point to give you an OD matrix of, among a set of locations. So it is something we do offer. They're not super common, but it is something we continue to offer. For larger study areas, though, we do use Streetlight. So I'm sure everybody on this call is familiar with Streetlight. They use LBS and GPS data to do OD. So we'll run those projects for you. We'll set up the gates in the ways you need them set up. We'll produce the reports and send that to you. We don't charge a very high fee for it. Usually the majority of it's a pass-through cost just because Streetlight bills us per data set that we purchase. So really you're paying for the data set in a couple hours of our time just to produce those OD matrices for you. Do you do any travel time data collection? If so, what are the tools programs you are using? Another good question. And funny you asked, I actually just got done doing travel time runs on I-77 yesterday, which was super fun, sitting in traffic for 3 hours. But we do travel time runs. We still do floating car method. That's a very popular way to go about it. For those, we use a QSTARS GPS logger that we'll set up on the dash, and it will just continuously log GPS points in 1 second interval as we're doing the back and forth runs. And then that stuff is processed in an application called TravTime. There's another one called True Traffic that we use, where we can actually go through and set up custom thresholds for congested and stop time. So we could say like anything between 5 and 35 miles per hour is considered congested. Anything below 5 miles per hour or 10 miles per hour is considered stopped. And then we can add in intermediary nodes. So say you want to know from point A to point B, but you're going through 10 different signals. Every one of those segments can be separated out to know the travel time from segment to segment. Or if you're doing an interstate like we were doing yesterday, you can do it from interchange to interchange. And then you have, your overall route data. So how long did it take you to traverse the route? How much stop and congested time did you experience? What was your average travel speed? All those kind of summary statistics you can get, but you also get it per segment, encompassing that entire route. So if you want to look at the data more granularly, we can divvy that up into smaller sections. And that is it as far as questions go. I'll give it another couple seconds in case anybody has any last minute ones. But if you need to bounce, I know I'm a couple minutes over on time. I really appreciate everybody coming to this. As I mentioned earlier in the call, we're going to have more of these over the coming months, focused on a variety of topics, going more in depth as to how we do the work, how we QA it, how we process it, how we deliver it. So keep an eye out for other invites, and I really, really hope to see you all at the next one. Thanks so much for attending.